All right, so in this lab, we're going to look at polymorphism. Polymorphic code, I think, is one of the coolest features of OO programming. It allows you to write some really elegant code and do some really cool stuff. So we're going to go through this lab. It's going to be a very simple example with students and a student interface and a grad student and a grade school student. And we're going to see how polymorphism, or one facet of polymorphism, in action. There's a lot of different ways to get polymorphic code. This is just one way to do it using interfaces. So let's head to the code. Okay, so welcome to polymorphism. So as I said, polymorphic code is really cool. So we're going to implement a very simple example. We have a student interface, and you're going to implement the student interface in the college student and grade school student files. I've given you the app.java, which has the main, with some examples that I want you to kind of work through and kind of demonstrate how cool polymorphic code is. So let's go back over here and just continue work through the README. Okay, so we want to implement our classes, then we want to write unit tests, and then we want to explore the app class. So let's go over and look at the test. So in this case, we're only going to write a test for the student class, and I'm going to group both concrete classes into this student test. So you can see here where I create a student reference variable, and it's of type student, right? Which means this student is actually representing this interface. Okay, and then I'm assigning a new college student to student. So you can see I'm actually assigning, this is a different type. College student implements student. So that's why I can now assign a college student object to the student reference variable. Super powerful. Okay, then I just got a simple constructor where I just set the name of Bob. Okay, then I just equal, make sure that the student is returning the correct name, and then is minor for college student. This should be false because college students are not typically minors. Well, in this example, all of our college students are adults, even though that sometimes it doesn't hold in the real world. That's okay. This is just for our lab. We go down to grade school student. You can see where I again have a constructor. Set it to the same interface. So look, I have student and I have a college student and then a grade school student. Make sure the name is set correctly, and then I assert true on is minor. So this is, I think I don't know if I said this wrong before. This is false, is minor, because college students are not minors. And then true is minor because grade school students, I'm talking about, K through 5th grade, they are minors. So you notice that I'm getting different results, right, from is minor. This one is returning, true, and this one's returning false. Probably the best way to demonstrate this is through app.java example. This is really cool. So you see here where I create an array list of students, and I'm doing 1, 2, 3, 4 adds, and I'm adding 2 college students and 2 grade school students. So I'm actually have 2 different type of objects in this single array list, which is awesome. Now, another cool thing is I got my fancy iteration here, which you'll learn about. So this is what's called a for each in Java. This is a for each. So it's saying for each student, and I use the variable s, and then this colon right here is what Java uses to denote a for each, and then students references back the array of students. So for each student in students, it'll loop until I'm out of students. So what I do is I just print out the name. So I said s.name. This s references this guy right here, s.name, and then I concatenate a string. I can concatenate a space. And then here's something kind of crazy, right? I say s.getClass, which gets me the class. So to get class, if you read the Java doc here, it says returns the runtime class of this object. So I'm going to get the class of this object. And then the class I call .getCanonicalName. So I'm calling another method on that object. So .getClass returns an object. And then I call a method, right? This is a method call on that return value. So s.get class.get canonical name, and the canonical name returns the canonical name of the underlying class as defined by the Java language specification, right? So this is called method chaining. So I can chain methods together like this, which is can be pretty powerful. So if I run this, it's going to produce some cool stuff, assuming that, obviously this is not going to run until you have these college student, grade school student implemented. But you can see here where I have, I print out the name. So Sam, Jen, Bob, Ann, which corresponds to what I put in, Sam, Jen, Bob, Ann. And look at this. This is the canonical name, lesson.college student, lesson.college student, lesson.grade school student, lesson.grade school student. That's really cool, right? And lesson is the package. So if we look over here, that's what that refers to right there, the package, the Java package. So that's cool, right? Because now anybody that extends the student interface can be thrown into this array list. And when I take it out, I know it's a student. So that's really, really, really powerful. It's unbelievably powerful. And one of the main enablers of cool and elegant object-oriented code. So that's the project in a nutshell. Once you get done exploring, writing your unit tests, implementing the derived classes, complete the retrospective as always, and then add, commit, push your code, and you're finished. So I hope you enjoy this project, and happy hacking.